Okay, great. So good morning again. This is our day 6 in the tech days that we are animating to introduce all the technology that you need in order to implement IoT, coding, robotics, microcontrollers, and hope that we are, as I've said before, responding to your need, and we are helpful somewhere in those webinars. I'll start today with the last workshop, which is for the series, which is the robotics. And I believe that this topic is really challenging, and I'll be trying to make it easy for you and to understand it in an educational way. I agree with you, and I want you to understand a very important notion that teaching robotics at school is really a must, since it's in direct relation with what we call the IoT, Internet of Things, artificial intelligence, machine learning, and mechanics, electronics, coding. So this skill, which is robotics, really should be given and should be acquired first by teachers and then by students. At the end, we are teachers. Me and you are teachers, and we understand that teaching robotics, it's not like a technical course where we have to take one robot and to manipulate it in order to show students how it works. Before reaching this point, let me be clear, please. Before reaching this point, you have to know that behind there is many steps that should be prepared. So I'll start my presentation. Why robotics in the curriculum ICT? So sorry, before this slide, I would like to emphasize that this course or this presentation today, it's not really a technical one. It's an educational process, and it's an educational track that you should follow in order to implement robotics in a clear and safe way at school. So let it be clear, and hope I'll be answering on most of your questions. So at the beginning, why robotics in the ICT curriculum? Actually, robotics is a skill each student must learn because of the following points. It is aligned with the coding chapters. It gives skills in to realize STEAM projects. It is in direct link with daily life projects, since robotics are implemented in agriculture, in medicine, in factories, and so on. It develops skills in communication and creativity, and it's a really a great introduction to Arduino. The following slide will be that robotics is divided into 3 main sections. So as teacher, you have to know that when you decide to teach robotics, you have to divide this chapter into 3 main parts, which are the theoretical part, the coding part, and the hardware part. And the theoretical part, in this section, students will be introduced to general notions and concepts regarding the world of robotics. In this section, so let it be clear, and I've highlighted in yellow and red, to be sticked in our memory. In this section, no need to have the hardware robot or even to be in the computer lab. So for those teachers who are asking themselves, can I teach robotics without having a robot in the computer lab? Of course you can, and we will be answering more and more to this question throughout the coming slides. So the theoretical part or section, it could be given to students without the need of hardware robot or even a computer lab. I mean, you can give it in a classroom where you have only a projector. The coding section or the coding part, in this section, students will make a link between all the concepts they have learned in coding in order to create robotics mission. In this section, in case the robot is not available in the computer lab, there is an option of creating simulated missions using the make code from Microsoft. So even for this section, in case you don't have the robot, okay, you can use a simulator in order to make students understand the word of robotics. So for the first and second section, as you can see, it is really clear and simple to have or to start this section and to implement it in the classroom. The coding section or the coding concept are the same independently from the robot brand. I mean, if you have any kind of robot, or even if you don't have robots, the coding section is the same for any kind or any brand of robot, since it's a concept of coding using variables, the condition statement, the looping, and other concepts. In the mechanical section, here the presence of a robot is really a must, since students are to explore mechanical concept and notions. And here, to be clear, for teachers even, those concepts are really will be new for them, since for ICT teachers who did not take courses in mechanics and in electronics, some notion will be a little bit new for them. So here they have to apply for this section with the presence of the robot, and they have to practice and try. And inshallah, hope things is going better, and I can revisit Saudi Arabia in the near future, and we can make and we can animate in presence real workshops, and you will be, of course, invited to participate to those workshops. So the major question that should be asked: shall we teach robotics for students in case we don't have a robot? The answer is, of course, yes. And here I insist on this slide. I mean, you have to teach robotics even if you don't have a robot in class, since the theoretical part and the coding section could be given without the presence of the robot hardware. Now, I will explore in a, let's say, in a quick way, the different brands that are available and that are educational, major educational brands. Okay, we have the EV3 robot, which you can see on my screen on the floor, which is made by Lego, and actually this robot is discontinued. They stop the production, but I know very well that there is many schools who have this robot. So they will continue for 1, 2, or even 3 years in using this robot, since it's a very good educational robot. There is the Vex Robot, which is similar to the EV3. There is a new robot also you can see on the floor, which is the MBot 2. And you have the fourth robot, also you can see it on the floor, which is the big one, which is the Shape Robotics. All those robots are educational robots. Actually, and this year during the last summer, it has been delivered a new robot, which is the MBot 2, and I know that it's really new, and I have one, and I've started experimenting the feature of this robot and how much it's really important to have it and to implement it in our curriculum, since it's the first robot where there is an external microcontroller that you can see here, and I'll be showing you later on. So this robot is oriented to what we call artificial intelligence, and with this implementation of the microcontroller, it's similar to the Arduino and to the microbit. So we have a microcontroller with a screen, with sensors, with a microphone, with speakers, and with LEDs, in order to create many scenarios in robotics. So this is an overview for the major educational robots that you can find in the market. Next, in this slide, teachers must know a really very important notion, which is which is in robotics, and you as teachers, since maybe there is some of the participants who don't have previous knowledge or information about robotics, all you have to know in robotics, it's all about to understand this relation between the brain of the robot, which is the microcontroller. And here you have to know that all the robots normally have brains, which are microcontrollers, and the relation between the brain and the input devices with the output devices. So once you understand this link between those three concepts, I believe that the journey of teaching robotics will be you will enjoy it, in other words, and you will be motivated and excited to teach this chapter or robotics in general. So in the next session, slide, excuse me, I'll be starting by exploring how to start teaching robotics at school. I know that there is participants who already started teaching robotics. They are not giving this chapter till now. So I've prepared a series of slides that you can use at your school. And of course, I'll be sending you this presentation. You can send me right now a gentle reminder in the chat. I'll be reading it at the end of this presentation. So those slides will be really important in order to implement this chapter within the classroom in a secure and educational way. So what I mean by session 0, it's like before you start the chapter, yani 1 or 2 or 3 weeks before you start the robotics chapter, okay, give your students a project to do at home. And in this project, they are asked to answer the following questions. What is a robot? Collect pictures of robot from real life. Where do we use robots? What are the components of a robot? And why not, if it's given for lower grades, I mean for grades 4, 5, and 6, why not to do this presentation or research with their parents? I mean, they can prepare it on, yes, yes, Salika, you have a question? Or Salika, just, I'm a little bit lost. This presentation on PowerPoint or written on a paper could be done or should be done before you start the robotics chapter. In the first session, okay, choose random students to present or to show their projects. So like this, you will ensure that there will be like a kind of communication or dialogue between and sharing information between students and you in order to see what are the results of this presentation. In session 1 also, I've chosen for you a random tutorial video from YouTube, which is educational, and it's really interesting to see it with your students. Of course, you can choose another videos. There is lots of tutorial videos on YouTube, but this one is really a cool one to make it clear. In session one also, watch with your students a video, 1 or 2 videos regarding what is IoT. It's really important. It's really important before starting the robotics chapter, since it's not a technical chapter, to make students understand what is IoT. And I believe we've talked about this concept many times. By watching those 2 videos, I'm sure that your students and will have a secure and enough information regarding this concept of IoT. So the first session is over, I believe, while presenting the PowerPoint presentation, watching the videos and watching the other video for IoT. Now comes the session 2, which is the preparation. And I remind you that for those who attended lately, that teaching robotics is divided into 3 parts. We are talking about the first part, which is a general introduction in order to introduce concepts. The second part is the coding part, and the third part will be the mechanical part, which is having the robot. So in session 2, we are still in the introduction phase, of course. Okay, you have to start asking a series of questions in order to make this interaction between you and your students, and even between students. And you will start by asking them those questions. And if you need, or if you doubt about any of the answers, I have all the answers for those questions in a technical and educational way. So I can be sending you those questions, those answers with the PowerPoint presentation. So what is a robot? Where we can find a robot? Can the fridge be considered as a robot? Examples of robotics missions. What is a brain? does the computer or a robot has a brain? Define a motor. Example of machines with motors. Speed and rotation of a motor. What is a speed of a motor and what is the rotation? So all those questions, if you doubt about how to give the answers for students, I can ask you gently also to send me request in order to have those questions. Since I will be sending the presentation in PDF, I don't know if the answers will be included. Okay, so please, some of the participants send me a kind reminder in order to send the answer for those questions. Other set of questions during the same sorry, just a second. Okay, for the same session are to define a sensor. What is a sensor? To give example of machines with sensors. Ask the question, does the lift has a sensor? Does the human being has sensors? And here the answer, just to make you a little bit, the answer for those, for the question 12, it's directly from teachers. No, we don't have sensors. But while waiting for a few seconds, you will hear from a few students, yes, we have the 5 sensors. So you will get the answer. Then the question 13, how many sensors the human being can have? And the question 14 is the difference between the human being and the robot sensors. Senses or sensors. And here the answer for this question is really clear, that the human being has 5 senses while the robot can have like 40, 50, I don't know. But the main difference between those 2 sensors are that we as a human being, we can say that, let's say, in the room temperature is like 20 degrees or 50 degrees, but we cannot get it in an accurate way. But a robot can measure exactly a temperature, the light intensity, distance, heart beating, humidity, and so on. So those questions are really important for the introduction of the world of robotics. And the question 15 is, why educational robot? So you will be asking your students that we have educational robot that we are going to show you in case you have one at school. But why educational? Simply because they are cheaper than the real one. Imagine yourself, you are buying a robot that make a car or a mobile phone. First, the price, the volume, how to program it. It's not made for education. And the major question for the major difference between a real and an educational robot, you will be waiting answer for your students, from your students, but for you as teacher, the main difference between a real and an educational robot is simply the precision of measurement. It's not the price, it's not the volume, it's not, I don't know what. All of those questions or examples are real. I mean, the real robot is much more expensive than the educational one, but the main information that students should acquire is that there is a major difference, which is the accuracy and the precision of taking information and measurement. Session 3, here I've made those slides regarding what we call the EV3 robot. But I believe that if you have another robot okay, you can replace those pictures with other to be aligned with the robot you have. But actually, as I said before, all robots have brains, have sensors, have motors, etc. So we are obliged to have one example. I've chosen the EV3 since it's the most popular robot at schools. And as I told you, many of you told me that they are using or adopting this robot. So the third session, in case you don't have a real robot or a hardware robot, and as I knew from many of the participants that next week you are going to be back, which is a good news to schools in Saudi Arabia. So it's a major step, and here you can explore more and more robotics in the classroom. So even if you don't have the robot, you can explore those slides in order to present the content of the hardware for students. So the session 3 will be to explore the brain, where students must know that in a brain there is a speaker, there is a screen, there is a brick button, which are the buttons that I'm using here. There is a battery, of course. There is input and output ports, which are from both sides. Depends from the robot. It could be from the left, from the right, bottom, or back. The USB port in order to download the program. And of course, the charger plug, where all the robots have those features in the brain. Of course, if you have the robot and you are in the lab, you can explore how to turn on and off the robot, since it's a little bit tricky for students. And you will start by exploring what we call the just one second. You'll start exploring the motors. I mean, if I'll be taking this robot, which is the EV3 robot, I have large motors. If I'll be taking the make code or the MBOT 2, I'll have two motors, two large motors. And if I'll take the third one, which is the robotics shape, also I'll be having motors. So while motors, simply because they are to ensure mechanical actions. So a robot without mechanical movement is not a robot, actually. Okay, so that's why it's really important to make students understand that what is a motor and how to use it, and the manipulation is the same for all robots or brands you may have. So there is a major question where to plug the robot, the rotation of the robot, which is equal to 360 degrees. Once we reach the coding part, you will be informed about more about this. So each rotation of the wheel of the robot is equal to 360 degrees. It's equal to one rotation. So here students later on will be obliged to make a specific calculation and to remember how to calculate the perimeter of a circle in order to calculate how many centimeters the robot will move forward in case it rotates for one rotation or more. The speed of a motor in robots, usually we measure it from 0 to 100, and this is what we call how fast the movement will be, slow or fast. Yes, there is a question. Sorry, can you raise your hand? Are you hearing me? Yes. Great. Okay, fine. So I was saying that those are the characteristics of the motors, in case it is called a large motor or any kind of motor or a medium motor. Here I mean by a large motor is the motor that makes the robot moves, and the medium motor, usually it's a smaller one, it's inside, you cannot see it, you will see it right in the next slide. And in this robot there is mechanical movement, like here there is a hand that is going up and down in order to catch a specific object. So those are the characteristics of the large motor. And for the medium motor, you can see this medium motor is made for the EV3 robot. So where to plug it, the rotation, the speed, so same specification. In the same session, which is the third session, you will be exploring also the color sensor that detects basic colors, could be used also for light, ambient light and reflected light. And ambient light to detect the light intensity in a room, and reflected light to measure the reflection and the light of the table. So I'll be showing you, for example, here in this robot, the EV3, this is what we call the light sensor. It's really small, it's one LED, and it is converted to color or light sensor. So you can use it to detect colors. This is what you have to say for students. And at the same time, you can use it to detect the light, the reflection of a light or the intensity of a light. In this robot, the MBOT 2, you can see you have 4 LEDs here, and those LEDs are to detect RGB colors and to detect reflection of colors. For this one, the Shape Robotics, also you can see that you have here sensors. I'll try to turn it on, maybe. So those lights or those LEDs are considered as sensors to detect colors and light in an accurate way. So as you can see, I've showed you that independently from the robot, a color sensor is a color sensor. Of course, the touch sensor also is a touch sensor. In case it's a Vex or a EV3, or we are not making advertisement for any brand. And the status, which is really important for students to understand, that the status of a touch sensor are 3. As you can see on the screen, there is what we call the, this is the touch sensor. So now it's released, it's not touched. Now it's pressed. So once it hurts a, let's say the wall, and or once it's bumped. So like this, it's bumped. So if the robot is moving on a table, let's say, and it hurts a ball or something, so it will bump. Okay. Next, we will have what we call the ultrasonic sensor that I have on my EV3 robot. And this ultrasonic sensor, this one, exists in it's the next generation of the ultrasonic sensor, which are more precise in the MBOT 2. And of course, you have them also in the Arduino. We've talked about this, if you remember, last sessions. So the ultrasonic sensor can detect motion and objects, the presence of objects. And in session 4, you will be starting by manipulating the software. Okay, so in order to recap what is done till now, I'll be summarizing in like few seconds to say that robotics is divided, for those who attended late this session, that robotics is teaching robotics is divided into 3 parts. There is the theoretical part that we've explored in the previous slides in order to try understand the world of robotics. And here it's really important for students to know this section, since you may ask me later, how can I create an assessment for my students? How can I make sure that students are getting those information and they are understanding those information? And more than that, as a teacher, I consider myself a teacher like you. I'm a teacher actually. So I consider myself failed in this mission if one of my students is asked by an adult and he cannot answer on those questions that are previously shown during the presentation. I mean those questions. So if a student, and let me be clear here, please, and this is really a challenge for you as teachers, more important than creating a simple mission in a robot to make it move forward or turn or I don't know what. For me as an educator, the most important part in teaching robotics is understanding this concept, and for students to be able to answer all those questions I've showed you during the session 2 on those. If the student can't have those answers, you mean we have failed as teacher to explain and to make students understand this concept, since creating a mission will be really simple for any person who can understand blocks and a little bit logic, but answering those questions are really a must for them, and it's really an important mission for you. So as I said, for the software, you have an offline application and you have online applications. For the EV3, which is a solution for the time being for those who don't have a robot in the classroom, even they can download the software. Sorry, for the teachers, excuse me, for the teachers who have the robot EV3, they can use it by downloading the offline application. This is one. Second, by not having the robot, okay, you can explore the online version of Microsoft, which is the make code for Lego. And this version also it could be manipulated online or offline. Okay, I mean, if you don't want to ask your students to download this application, you can go to the online version, which is https://makecode.mindstorms.com, and there they are going to explore this this application without any problem. And in addition, they will be seeing the robot virtually. Of course, they will not see the robot make movement, but at least they will explore and understand this relation between the brain, the input-output, and those scenario of creating those programs. So as you can see here, let's say I'm showing you a few examples of a mission where when you will start the mission, the status light of the robot will flash red, excuse me. If you click on the button of the brick, the button down, the robot will move at a speed of 50-50 for one rotation. And if you press the button up, the robot will move back at a speed of 50 for -1 rotation. Here, I want to clarify something very important, which is what does they mean by a tank? A tank, actually, it's the robot. This is the tank. It's the tank. So it's the robot. And when you order to move the motors of the tank, B, C, so you are asking to make those two wheels turn. And as you can see here, I don't know if it's clear or not. So the ports of the motors are labeled by A, B, C, D. I don't know if it's clear or not, but you can see it from any picture that you collect if you don't have the robot. Here is another mission, which is at the beginning of the mission, the status light will be flashing red. If the button brick is pressed right, the message hello world is displayed. And if the brick button left is pressed, a smiley face will be displayed. So as you can see, it's a scratch-based programming concept. Okay, this mission will show, excuse me, this mission will be executed once and only when the touch sensor is pressed. So as you can see here, on touch connected to port 1 is bumped, and I've told you, sorry, what does the bump mean, which is I press and I release. And once this touch button is bumped, the motor tank will move. And if the distance of the ultrasonic sensor is less than 10, all motors stops. So what I'm trying to tell you here, that, and knowing that you were teaching online, and maybe inshallah no, but no, at any time we can go back to teach online. The main target that you can point to while teaching robotics is to develop this critical thinking of giving an algorithm and ask your students to transform it to a robotics mission. If you reach this point, and even if you don't have the physical robot, for me as a teacher, you've succeeded in the mission. in your mission. So in other words, once you did the introduction for your students and you showed them the software and so on, you are asked to give them algorithm of samples of example, and they have to be able to reproduce the mission according to the algorithm you gave. Here, if I want to translate the mission you are seeing, okay, what is the algorithm? It's very simple. I'll be asking my students, create the robotics mission in order to make the robot move at a speed of 50 when the touch sensor is pressed, and stops once the ultrasonic sensor will detect an object at less than 10 centimeters, as shown here. So the algorithm that I gave you right now, if your students are not, it's considered a little bit difficult and advanced somehow, since we've integrated 2 sensors, but we can make it more simple by integrating, let's say, 1 sensor, or I don't know. So my question or my idea is, and I will repeat it since it's really important, and you have to take it into consideration, that teaching robotics, it's a must, and understanding the concept is also a must. Coding is really important, and if you don't have this robot between your hand, you can create virtual missions, and then after you can develop skills in order to make sure that your students understand this relation between the algorithm you gave or you are giving with how to transform it to a robotics mission. I believe here, for this example, you can see that there is only 1 sensor, which is the ultrasonic sensor. The mission will run forever. Only when the ultrasonic sensor detects an object less than 10, the robot will stop. So even if you remove your hand for more than 10 centimeters, here the robot will start again moving and moving. So this is how we can experiment. This is how we can experiment examples in order to make sure that teachers are really understanding. This mission will run 4 times. As you can see, when the touch sensor is pressed, the screen will display blinking, opening eyes, and then it will clear the screen 4 times. So I can assure you that there is hundreds of scenarios and algorithms that you can practice during teaching robotics, even virtually. Okay, I will not forget, but if you can send in the chat, since it's the conversation, it's saved, if you can send me a kind reminder to send you example missions of robotics with algorithm to explore them with your students, since in our curriculum we've explored the software Mindstorm and not the Make Code, since it's a new software done. And then here I'll be going through, I will not go through all the slides, but you will, for those who are not using our curriculum, I invite them highly to try, even for few grades. And Mr. Muhammad Nuruddin is with us. He can share his phone number with you in Saudi Arabia in order to send you a specimen or to make you a visit and to explain you more and more the content. But as you will see here, the content and the layout of the books are really attractive and really informative and educational, in order to make students understand and interactive at the same time, understand the concept of robotics. As you can see, there is many exercises inside the book where students are asked to do. This chapter, for those who are using our books and they have the EV3 robot, this chapter is available on the make code. So you can request it and we can send it to you for sure for free as a PDF on our digital platform. So as you can see, the grade 4, the grade 5, so all the pages are well done, attractive, simple, full of interactivity and exercises, in order to make sure, and you can get inspired from those missions, in order to make assessment and short quizzes for your students. So for this presentation, it's done. I'll be showing you another software, which is the M-Block software. Please, can somebody raise his hand to make sure that you are seeing my software? Okay, great. So what is this software actually? This software also is a software which is a block-based software and a Python software, where you can explore using the robot MBot 2, the one I've showed you right now. I'm not seeing myself. Okay, so this robot, it's explored and manipulated in this software. And as I've said before, it's a really new robot, and it's the only robot considered to be used with this external microcontroller. This microcontroller has, as I said before, inside sensors, a screen, speaker, microphone, LEDs, and push buttons. So this just one second. This microcontroller could be manipulated, and really it's an advanced feature in this software. This microcontroller could be connected directly to the as you can see, it's already on. Okay, and you can control it by this software by using what we call the CyberPi. It's the CyberPi. While I'm really excited for this robot, since as you can see in the screen, you have what we call the AI blocks and the IoT blocks and the sensing blocks and the motion blocks, in order to make this robot #1 in teaching and introducing artificial intelligence and the machine learning and the world of IoT. So you have to find a way to start those concepts from a point, and this is really the point where you have to start with. So you can explore the CyberPi features that are included in this software. Okay, and all the blocks are here to do that. Today I'll be making just an introduction, and once I'll be finishing my curriculum for this robot, since it's really new, I'll be conducting a new webinar dedicated only for this robot to show you the features of this one. And of course, once this this microcontroller could be connected to this robot in a simple and easy way by clicking the robot, the microcontroller on the robot. And after that, you can go to the extensions from down. And as you can see, you have what we call the MBOT shield with the quad RGB sensor and the ultrasonic sensor in order to start working with the robot as an entire robot. So here, to make it clear, with this robot, you can explore and animate sessions with your student using only the CyberPi, which, by the way, you can have it without the robot. I mean, you can buy it. And this is really important, since this robot, you can buy it from the agent in your country, and even you can order it online by choosing Amazon or AliExpress or any of the online stores. So no problem for that. And as you can see down, all the extensions that makes this robot interactive and related to the Internet of Things and artificial intelligence are here. But of course, you have to buy the hardware, but it will be for a later step. So you have the soil moisture, the magnetic sensor, the AR, the speakers, the MQ2 gas sensor, and so on. So you have many pages of sensors that you can explore with. So by adding, I think I did not add the MBO2. So let me add the MBO2 shield in order to, admit. So once the MBOT2 is here, you can explore the blocks to make the robot move, turn, with the combination of the CyberPi feature. So to conclude and to respect the time given for this session, which is 1 hour, and to give you time for questions, I'll be concluding by saying that the EV3 robot was leading the market for like 8 years from now. They decided to stop the EV3, the company Lego, and to switch for another robot, which is the Spike robot. Me as an educator, I believe that it's a step backward in the world of robotics, not a step forward. Now, what is leading is this robot, which is the MBOT2, since it's related and connected to IoT with the CyberPi, especially that you will notice that the price of this robot is less than $200 US. The EV3 robot was like $600 US, so times 3. So budget-wise, you can convince your school to adopt it easily, and all the support that you may need, you will have it from us, since we are going to be the first to develop this robot, a curriculum for this robot. And for all the schools that are adopting our curriculum, we have a strategy on helping them in a way to have those robots in a discounted price, in order to motivate them and to encourage them to have this robot. I'll be preparing a next session for this one, promise. Now, I'll be giving you, meanwhile, the link for the robotics session in order to fill the so here I'm the link. Okay, copy the link. Okay, I'll be sending in the chat. I'll be sending everyone in the meeting the chat, the Google form It's not sent. Okay, it's sent now. So will you please go to this Google form and try filling your personal information in order to prepare you in the near future the certificate of participation. Okay, and then I will be stop recording this. I'll stop sharing. Sorry. I'll stop sharing. And then I will make you unmute, since I'm seeing that there is many of you who have raised their hands. So I'll stop